Hey guys, Mr. Bragback here to talk about energy and energy transformations. This is lecture 2, and I'm going to start off with we are talking mostly about our um, investigate and the different energies that we saw qualitatively and how we can take these qualitative pieces of data and turn them into quantitative pieces of data. What I mean by that is that qualitative is things that we see. How do we take the things that we see and turn them into actual numbers that we can use? So first of all, let's talk through what we should have seen is that when we were in the down squatting position, we mostly had leg muscle potential energy or elastic potential energy in our muscles. Our muscles were ready to go. And when we sprung up using the potential energy in our legs, that energy became gravitational potential energy and kinetic energy. And then over time, once we got to the very top of our jump and we started to slow down, and almost just before we started to go back down, everything in our peak position was all gravitational potential energy. So now they just kind of assign different numbers to, let's say, our body mass, how much our mass is, and our weight. So let's just say the weight is 430 newtons because the mass is 44. And it goes through the different heights, the ready height, the launch height, the peak height. But overall, what they're looking at is the jump height. All right. So the launch height is 2.05 and the peak height is 2.65, which gives you a jump height of 0.6. And so what they're saying is on Earth, that's going to take to jump up 0.6 meters and have a mass of 44 kilograms. That took 410 joules. And the way that we know that is simply by taking the force and multiplying it by the distance traveled. All right. Now, we could do the same thing on the moon, except on the moon, the person's mass is actually a little bit different. It's going to be 70 newtons rather than 430. So you can imagine, because of this, if we have the same amount of energy, if I were to jump on the moon and jump here, I'd obviously be able to jump a lot higher on the moon. And so what they're saying is that um, if the launch height is 2.05, like you'd think the person is going to be the same height on the moon as they are on the Earth, so the launch height should remain the same. Then the peak height would be 7.6, or the total jump height would be 5.55. Given that the energy, I should still have the same strength in my legs on the moon as I do here on Earth, and so my jump height is going to be a lot higher on the moon because the moon doesn't pull me down nearly as much. And because of the fact that we have the conservation of energy is 400, 410, then all 410 of that energy or work that I do has to go into the potential energy on the moon. All right. You have to consider on the moon that acceleration is only like 1.6 rather than being 9.81. And so we can jump a lot higher. So that's pretty much it for this lecture. If you have any questions, make sure you write them down. Other than that, I'll see you guys in lecture 3.